Assalamu alaikum student. Today we discuss the topic that is the heat capacity. What is the heat capacity? If we define a definition, heat capacity of a body is defined as the amount of heat required to change its temperature by 1 degree centigrade or by 1 Kelvin. Now we discuss the heat capacity by the example. Here we take the water in the container. In this container, I take less water. In this, I take more water than this container. I supply same amount of heat to both of them. When apply this amount of heat, 100 joule, it increase the temperature 60 degrees centigrade. If apply same amount of heat to this container, it increase the temperature 30 degrees centigrade. It means that if take more quantity of substance, it take more heat to rise up its temperature. If we take the less quantity of substance, it take less heat to rise the temperature. So here we write less water take less time to rise in temperature, absorb less heat. So we conclude that if less mass, then it has minimum heat capacity. In this case, if we give the 200 joule of energy to same container, then it rises the temperature 60 degrees centigrade. It means if we give the more mass of water, give more heat, then its temperature rise to 60 degree centigrade. So if we take more water, it takes more time to rise in temperature. It absorbs more heat. It means that because it has more mass, if it has more mass, then it has maximum heat capacity. So we can define the heat capacity by formula C, change in energy, our change in temperature. If we rise in temperature delta T, we give it amount of heat delta Q. Now we discuss it units. Its unit is joule per Kelvin or joule per degree centigrade. This is all about the heat capacity that is today we discuss. Now we discuss the specific heat capacity. What is the specific heat capacity? First we discuss the definition. What is the definition? Is the amount of heat absorbed by a gas of 1 mole to change or rise its temperature delta T. Specific heat capacity is intensive property. It means that it does not depend upon the mass. We can understand it with the example. Here we take a container that is full of the gas molecules. Let's suppose they have the n mole of ideal gas that is represented by n. If we give the delta Q heat to rise the temperature delta T, then its specific heat capacity, we can define it by capital C, that we give the heat to n mole of an ideal gas to raise in temperature delta T. Here we understand it with the example. Example, we take the 1 mole of ideal gas. We give 4000 joule of energy for rise in temperature 1 degree centigrade. So if we have 1 mole, if we take 5 mole instead of the 1 mole, we know that for 1 mole of ideal gas, we give the 4000 joule of energy. So if 5 mole of ideal gas, so we can calculate it energy by using the energy of the 1 mole of an ideal gas to rise in temperature 1 degree centigrade. We multiply the 4000 joule of energy by 5 and we can get the energy for 5 mole of ideal gas to rise in temperature 1 degree centigrade. So it means that we give the 20,000 joule of energy for 5 mole of ideal gas to rise in temperature 1 degree centigrade. So here we write specific heat capacity is independent to mass.